So the third video on our notes, we'll go through some of the other concepts here. All right, start playing. The segment addition postulate will be used when we get into proof. Right now, we're just going to go through it to have the notes there. When 3 points are collinear, A, B, and C, then AB plus BC equals AC. Seems like a pretty simple concept. The key there is that the points have to be collinear for that to work. The one thing we're noting right now is when I write AB, there's usually a segment symbol above it. This time there's no segment symbol. That's because it means it's the length or the distance between the points A and B. Okay, AB with the bar is a segment. AB without it is the length of that segment. All right, congruent segments are going to come in a lot of different ways this year. The first one I drew quickly was if I have a slash like this, that's our symbol on a diagram that two segments are the same. Now, the other way we can show segments have the same length is we're going to calculate their lengths. Okay, that's going to be on a graph. So let's say I calculated the length of two sides to be 8. Okay, because they have the same length, I can say that they're congruent. So there's their lengths are equal. I showed that. So then they're congruent. We're skipping constructions for now. They may come back if we go back full time. But for now, we're going to skip them. For chapter 2, midpoint of a segment. This is going to be pretty popular. First, we'll just go off the grid. It's not going to be on the graph yet. There is a midpoint formula on the graph. It's going to be the point that divides segment JL into two congruent segments. So again, I didn't have to say this. It's kind of redundant. If K is the midpoint of JL, it's implied that they're collinear. So I really didn't have to write that they were collinear. If it's the midpoint, skip the collinear part and just go right to JK is the same as KL. Okay, what I'm doing right now is I'm setting up the midpoint formula eventually. Let's just go one-dimensional, meaning let's just go in the X direction. Okay, so if A were at -5 on a number line and B were at 9, we'd want to find the midpoint. Now, I know I didn't place it perfectly in the middle. What's going to happen a lot in this course is the drawings are not going to be to scale. So I messed up on the actual picture, but my numbers and what I say are going to take over that. So drawings are not to scale is always going to be something that's stated. So now we want to find the midpoint. We're going to have to find the average of -5 and 9. So add them together to get 4, and then 4 divided by 2 is going to be 2. Okay. All right, segment bisector. Now a midpoint is a way to bisect a segment. So that's why it says, well, it doesn't say actually that a point can, but it can. So we've got a ray, a line segment, or even a plane that basically intersects or cuts the segment into two equal parts at the midpoint. Okay, so there could be an extra step by saying it's a segment bisector. We should be able to jump right to CM is the same as MD. We could say that M is the midpoint as well, but we can go right from bisect to congruent. Now, one extra piece of this is there's no guarantee EM is the same as MF. So watch out for that, okay? That's important. When EF is doing the bisecting, okay, that does not mean EM and MF are the same. It doesn't mean that CD also bisects EF, okay, for a couple reasons. All right, first, EF, the line, that didn't get bisected. We don't know if M is the midpoint of EF. All right, so don't get fooled by that. All right, an angle, it's two rays, but I'd rather call them sides. So you're going to hear me this year calling a side GH and side IH, or mark the two sides of the angle. we're not going to say mark the two rays. And I'm even stating them as segments, but they can be rays or segments. So two sides and a vertex. We talked in class a little bit about how to name an angle, 3-letter path, right? So H is actually where the vertex is located. And to form the angle, we follow the path G to H to I. So we're talking about that space in between the two sides is the angle. All right, and that's what it's going to be talking about here for a second. Think of an angle as the space between the two sides. All right, a couple more. Actually, acute angle. I'm not going to go over that much. You guys know what that is. It's going to have an angle measure that's between 0 and 90. Oh, a right angle. Just get used to that. We know it's 90 degrees, but we also want to get used to this symbol. You probably already are. So like I said, I'm not going to spend a lot of time on things you already know. Obtuse angle, greater than 90, but less than 180. Straight angle should be new to you this year. It's exactly 180 degrees in measure. Okay. Straight angles measure exactly 180 degrees, just like right angles measure exactly 90. Okay. There's going to be no symbol for a straight angle. We might say this. Okay. I think, I'm not sure if I wrote it down. AB, yeah. Okay. So what I could say to show that it's a straight angle is A, B, and C are collinear. That's a way that I could kind of trick everybody into, or just kind of indirectly, not trick, but indirectly state that angle ABC is a straight angle by saying A, B, and C are collinear. Okay. One other thing that will come up is BC, okay, that ray, and BA, that ray, they have the same endpoint. Okay, we talked about that, a little tricky. Think of BC as the straight path and it ends at B, right? So tricky there. These rays have the same endpoint, and together they make a straight angle. They are going to be considered opposite rays. Okay, a couple more. So congruent angles, they're going to have the same measure. We're going to throw symbols in there like that. Okay, they're going to be arcs. We're going to work on that. They're offset a little bit, so I'll show you that. 72 degrees. Angle bisector is going to be any ray, line, or segment that divides the angle into two congruent angles. Okay, so if GI bisects angle FGH, right? Then this top part, this top angle FGI, has to be congruent to this bottom angle. Okay, and that's what that's going to show, and that's what those arcs are showing. All right, I think this is it. Right angles, all right angles are congruent to each other. So if I draw a right angle anywhere and then another right angle in another location, they have to be the same. They have to be congruent. Okay, even if they're not right next to each other, they have to be congruent. Okay.